express this equation in terms of p. So class, what we'll do is we should be able to make the laws of indices. So with the laws of indices, you know this, that as I had indicated earlier on, if you have a to the power of n, then times a to the power of m, then basically that is a to the power of n plus m, like that. So I want to use that here. So instead of me writing 3 to the power of 2y minus 1, then this is the same as 3. That is the same as 3 to the power of 2y. That is 2 to the power of 2y. Then times 3 power negative 1. Then this is plus 2 times 3 power y. Then times 3 power negative 1, then this is 1. But you see, we have been given the value of p as 3 power y. So I'll go ahead and further split this one here. So if I split that, then that implies that I should be able to have it as 3 power y times 3 power y times 3 power negative 1, then this one plus 2 times 3 power times 3 negative 1, and all this is equal to 1. But now already we have been given a value of p as 3 power y. So where we have 3 power y, we substitute for p. So that means that this is going to be p squared, then times 3 power negative 1, then plus, now this becomes 2p, then times 3 negative 1, then this one is equal to 1. So my class, you know this, that 3 power negative 1 is basically equal to 1 all over 3. So here now, that implies that my p square times 3 power negative 1 is the same as p square, you divide by 3. Then plus 2p, you divide by 3. Then this one you say is equals to 1. So what follows next here is that I may opt to eliminate this fraction, and that implies that I multiply by 3 all over. And if I multiply by 3 all over, then that means I'm going to p square 10 plus 2p is equals to 3. And once again, we might want to really rearrange this to be able to form another quadratic equation, of which we need to solve and be able to find the value of p. And of course, we know that p is equals to 3 to the power of y. So basically, I'll have p squared then plus 2p minus 3 is equal to 0. So I'll want to factorize, and in so doing, it implies that I need numbers whose sum is 2 and whose product is negative 3. And if I find those numbers, we refer to them as factors. So two numbers that you can multiply to get negative 3 and you can add to get 2, then those numbers are negative 1 and a positive 3. So these factors now, I'll use them to express p in terms of negative p, then plus 3p. So that implies that I'm going to have these as p squared, then perhaps I would say plus p, then minus p minus 3 is equal to 0. And what I should be able to really follow next is I group into 2, and I said if you have to, perhaps you can underline, but not by use of a bracket. It gets to change the meaning. So what is common between p squared and 3p is p. So if I pull it out of p, I'll remain with p. And if I pull p out of 3p, I'll remain with 3. Then what common between p and 3 is simply 1. So if I factor out 1, I'll remain with p plus 3. And this is equals to 0. So you realize that on the first part of the question, I have plus 3. And on the second part of my factorization, I once again have 3 plus 3 plus 3. And what follows next is I have to factor out plus 3. And if I factor out plus 3, I remain with p minus 1. And all this is equal to 0. And class what follows next, we say that either, we know that either p plus 3 is equal to 0 or p minus 1 is equal to 0. So from the first one, it implies that p can be 3, and from the second one, it implies that p can be 1. But what was our p? Our p, we were told, was equal to 3 to the power of y. And what was the question asking us? The question required that we be able to find the value of y by the end of it all. So good. So that implies that we should be able to now say that 3 power y is equal to 1. But we know that 1 again is the same as 3 power 0. So from here, it implies that the value of y is equal to 0. Then what of when p is negative 3? So when p is negative 3, then perhaps we say that 3 to the power of y is equals to negative 3. 3 to the power of y is equals to negative 3. And one of the ways of solving this is by introduction of logs. And when you introduce a log, then we are going to have the log of 3 power y is equals to negative 3. But of course, class, you know here that perhaps what we have here is tensor. I have introduced a log on the right hand side, so that should be equals to the log of negative 3. So class, when you know on the left hand side here, I have log of 3 power y. So basically, what we do here from the laws of logarithms, we can drop this power behind here, and that implies that I'm going to have y log 3 is equals to the log of negative 3. But I want to really remind you that when dealing with the natural logarithms, we do not have the log of a negative number. You can just confirm from your calculator if you can find the log of negative 3. You can't find that log, it is an error. So then that implies that if this were to work, then perhaps the value of y could have been the log of negative 3. You divide by the log of 3. But I have made it clear that with natural logarithms, we do not have the log of a negative number. And therefore, we'll end it here and conclude that the value of y must be 0 for the equation to hold. That is fair enough. Yeah, that is fair enough. Next, I want us to look at the next question. And the next question is the next question is this one here.